Hello friends, I welcome you in lecture number 11 on exponential distribution. In this lecture we will discuss one more example on exponential distribution. Now before going for this example, we just recall the formulas required for this problem, and we know that whenever we are interested in the waiting time between successive events or waiting time until first event, then this random variable is a continuous random variable and it is having exponential distribution with mean equal to average waiting time between successive events. If I consider average time between successive events, then that is nothing but mean of this random variable, and we denote it by mu. We will also have this parameter lambda, which is nothing but average number of events per unit time. So sometimes we will be given this value of mu in the problem. What is mu? It is average waiting time between successive events, or we certainly write that average time between events. Our random variable capital X is time between events, and if we have average time between events, then that is nothing but mean of exponential random variable. So sometimes in the problem they specify the value of this mu, or sometimes they are giving the value of lambda, which is nothing but average number of units per unit time. And we know that mean and lambda are related by this formula: mean of exponential random variable is equal to 1 divided by lambda. We also have discussed that CDF of exponential random variable is given by fx equal to 1 minus e raised to minus lambda x whenever x is non-negative, and 0 if x is negative. So this lambda is nothing but this parameter, average number of events per unit time, and we call it as rate parameter. Mu is the average time between events, and lambda is reciprocal of mu, that is average number of events per unit time. This mu is nothing but average time between events. If we are talking about mu, then it is average time between events, and lambda is nothing but average number of events per unit of time. So they are reciprocal of each other. And we have discussed that whenever we are interested in this type of probability that x lies between a and b, then we will integrate probability density function from a to b. We have another way to calculate this probability using this CDF also. We know that if we have probability that x lies between a and b, then this we can rewrite as probability that x is less than b minus probability that x is less than a. Now this is nothing but value of CDF at b, and this is value of CDF at a. We know that CDF, using definition of CDF, we have f of b is equal to probability that x is less than or equal to b. But we know that if x is continuous random variable, then probability at a single point is always 0. So these two are equivalent. So therefore either we are writing equality or inequality. For exponential random variable it does not matter, because probability at a single point is always 0 if x is continuous random variable, and here x is exponential random variable which is continuous. So we can use this formula instead of taking integration of probability density function. So there are two ways to calculate this type of probabilities: either we integrate probability density function of exponential random variable, or we can use definition of CDF. So with this in mind, we try to answer this question, or we try to solve this problem. What is given? The average time between incoming calls at a call center is given as 10 minutes, and we have to find the probability that the next call comes within 5 minutes. So first we write down what is given random variable. Random variable is nothing but time between calls, and it is given in minutes. Time between calls in minutes. Here our unit is minute. And what is another thing given is average time between incoming calls at a call center is 10 minutes. That means we are given the value of mean time. So first we can write that given that average time between incoming calls, or simply I write as between calls, is 10 minutes. That means we are given the value of mean and it is 10, and we have to calculate the probability that the next call comes within 5 minutes. So for that we will require the CDF or PDF, and for that we will require the value of lambda. So we know that mu is equal to 1 by lambda. So lambda is nothing but 1 divided by mu, that is 1 by 10, and this we can rewrite as 0.1. So value of lambda is 0.1. Therefore we can write the cumulative distribution function of exponential random variable x as fx equal to 1 minus e raised to minus lambda into x, and lambda is 0.1. Therefore we write fx as 1 minus e raised to minus 0.1 into x, and here x is any non-negative real number. Now we have to find the probability that the next call comes within 5 minutes. That is, the time until next call is up to 5 minutes. Okay, now we write that what is required. We have to find the probability that next call comes within 5 minutes. That means the time until next call is less than 5 minutes. And here we have defined x as time between calls, but because they have asked the probability that we have to find the probability that next call comes within 5 minutes. So we can, instead of this, we can write that time until next call in minutes. So instead of writing time between calls in minutes, we will consider capital X as time until next call. Now capital X is time until next call, so that is our x. So here we write probability that capital X is less than 5, and we know that probability at a point is always 0 for continuous random variable. So I can rewrite this as probability that x is less than or equal to 5, because I know that probability at x equal to 5 is 0 because x is continuous random variable. And if you recall the definition of CDF, it is fx equal to probability that capital X is less than or equal to x. So if I use in reverse way, if I have probability that x is less than or equal to x, then that is equal to value of f at point x. So if we compare this with this, then we have x equal to 5. So this is by the definition f of 5. Now what is fx? Fx is 1 minus e raised to minus 0.1 into x. So here we will have to write x equal to 5, because we are interested in the value of CDF at 5. So this will give me 1 minus e raised to minus 0.1 into x. X is 5 here, and this is e raised to 0.1 into 5, that is 0.5, and using scientific calculator up to 4 decimal places I find that this is equal to 0.3935. So in this way I can use CDF also to calculate the probability related to exponential distribution. If you don't want to use CDF, then from this step you can go using PDF also. This is equal to integral of probability density function. Upper limit is 5, there is no lower limit, that means minus infinity to 5. And we know that if x is negative, CDF is 0. So we will have non-zero CDF from 0 to 5. And then we can write down PDF and we can integrate it. For this problem, what is PDF? PDF is given by lambda into e raised to minus lambda x. So if I take lambda equal to 0.1, I will have e raised to minus 0.1 into x. So if I want to go in this way, here I will put fx equal to this value 0.1 into e raised to minus 0.1 into x, and I will integrate with respect to x. So in this way also you can check, you will get the same answer. So either use CDF or PDF, you will get the same answer. What you have to remember is that whenever we have this type of variable, time between events or time until first event occurs, then we will use exponential distribution, and for that either we will be given average time between calls, that we will denote by mu, or we will be given lambda. Lambda is nothing but average number of events per unit of time. So they will specify either mean time between events, or they will give you the value of average number of events per unit time. So we will require lambda. If lambda is not given directly, then we can find out lambda using lambda equal to 1 divided by mean, and either we can use CDF, which is given by 1 minus e raised to minus lambda x, or we can use PDF, which is given by lambda times e raised to minus lambda x. In both the way we will get the same answer. If lambda is given, then you have to make sure that lambda is given per unit time. For example, if your time is in hours or in minutes, suppose your variable is time between events in minutes, then you have to find out lambda as average number of events per unit of time. Here time has unit minute, so here you have to find out average number of units, average number of events per minute, that is per 1 minute. That you have to remember. So this is all about this lecture, and we will continue with this type of problems in upcoming lectures. Thanks for watching.